I will delete the whole thing by clearing it, and I will enter this function. Negative 0.0011x squared plus 0.0412x plus 3.02. No, 3.032. 32. Okay, I'm checking. Yes, yes, yes. Everything appears to be okay. Good. I go exactly to second and table, and I only want to plug in 13, and I want to plug in 30. I don't want to calculate this by hand or just punch it in twice. So this is 3.3817 millions.
Can I ask how you get to the table? Because I can't figure that out.
Second and table. Second and table. Second and table.
Second and graph. I keep pressing that, but nothing is happening.
Second.
I kept saying quit. Yeah.
Second and table.
Yeah, that's what I'm pressing. Oh, found it. Thank you.
My pleasure. But remember, you have to do second and table set first. You have to make sure that this is in ask mode. Scroll down, go to the right and highlight and press enter. Because otherwise it will not allow you to punch in the numbers you want. So this is what I recommend. And I think we had enough of this. Let's continue, unless you have questions for me. Any questions for me? Anything?
When you do the second and table set, at the top it says table start equals.
It doesn't matter. If you remember, I said don't even worry about that. It doesn't mean anything.
Okay.
You only want to be allowed to enter the numbers you want. That's all you care about. That is that that number can be changed into anything you want because you want the table to start at a particular value. But it doesn't matter because in this particular case, you are entering the numbers you want. Now, if you change this to auto, then this makes sense. But once you have it changed into ask mode for the X variable, you are entering, you dictate what you want. This means nothing now. Good question, very good. Anything else? Other questions here? Okay, I would like to talk about, now we're continuing with R.2. We're still reviewing, and R.2 deals with functions and models. And since we are here and I don't want to forget, R.1 is due Tuesday in MyLab Math because it's complete. Okay? And if you find something that we did not go over, please bring it to class. But it's complete. It should be done completely by Tuesday. Okay, about functions and models. We're going to look at some graphs and everything in a minute. I'll open the book again to this and we'll refresh our memory. But what I would like to talk about right now is, number one, piecewise defined function and graph. So first of all, what is it? What is a piecewise defined function? Exactly what it says. It's defined in pieces. So here's one example, and I'm making the numbers up. I do not know the tax code. I'm not an accountant. I was not really interested in knowing too much about how the tax code works. But taxes are, or the way taxes work, are exactly an example of a piecewise defined function. How come? Well, I'm making stuff up now. For somebody who makes between 0 and, let's say, $30,000, the tax code requires this person to pay, I don't know, 4%. For someone who does not make 30, but more than 30, let's say from 30 and a dollar to 60, let's say the tax code is 8%, and so on and so forth. This is the piecewise defined function. For this domain, this is the function. For this domain, this is the function. For another domain, it's a different function. Another example of a piecewise defined function would be, maybe it's not applicable anymore, but it's applicable when we buy in bulk, for example, right? So let's say phone bill. In the past, you're too young probably to remember that, but the phone bill sometimes would be between 0 and $1,000, you pay 25. 0 and 1,000 minutes, you pay 25 per month. Between 1,000 and 1 and, I don't know, 5,000, let's say we pay 35 a month, and so on and so forth. So that's another example of a piecewise defined function. For this domain, this is the function. For this piece of the domain, this is the function. For the next piece, a different amount. Okay, and now I would like to choose a piecewise defined function and graph it, evaluate. Let's start with evaluating, but does graphing and evaluating mean the same thing? Okay, so this is on page 23. I'm going to open to page 23. And if you want to choose, you're more than happy. I am more than happy to. 23. Choose a piecewise defined function, and let's run with it. We need to graph it. We need to understand what it means, yada, yada. So feel free to choose. If you
71.
don't, which one?
71.
71. Good, 71 on page 23. Perfect, let me copy it. And then this is g of x, 1/2 x minus 1 for x less than 2, -4 for x equals 2, and x minus 3 for x greater than 2. Excellent pick. Perfect. Every time we are asked, is this a piecewise defined function? Yes. For this domain, between -∞ and 2, and I'm going to write it on the side right now. I hope you agree that this represents -∞ and 2. For this domain, this is the function. For this domain, which is just x equals 2, this is the function. For this domain, can anyone give us the domain in interval notation for this piece?
2 to positive infinity.
Awesome. Very good. Great job. So every time we're asked to graph a function, remember I said that last time, number 1, domain. Okay, can anyone give us the domain of this function? This function, not this. Can anyone give us a domain of this function?
Is it -∞ to positive infinity?
Brilliant. Who was that?
Naja.
Thank you, Naja. So I see here everything to the left of 2. I see 2, and I see everything to the right of 2. So obviously, nothing is missing. This is not always the case. But in this particular situation, everything is there. Perfect. My next step, number 2, is the table of ordered pairs. Plugging in the domain in the table, putting in the, sorry. G of x. Good. Looking here, I'm hoping you will tell me what is a very important point or x value. What is a very important x value here?
2.
Yes, of course 0 has to be in the table, but 2 is an important value. Why? Why is 2 an important value? 2 is an important value because something crucial happens here. At 2, the function on the left is this, at 2 is this, and on the right is this. So as you've noticed, I have these parentheses here, and this, at 2. So I'm going to use them. They're not touching because when x is 2, y is -4. So when x is 2, y is -4. But I have these parentheses, one facing left, and the other one I'm copying it here facing right. I also make myself a note. You can say this is an unnecessary note. I would accept that, but I will always put it in. I check and make sure because these may be scrambled here. They may not be in the correct order, but it happens that they are. From x between -infinity and 2, 1/2 x minus 1. At 2, -4. It's already in the table. And from 2 to infinity, I have to copy x minus 3. You can say, why are you copying them? Don't you see them over there? I do. Just for safety. Now I realize that these are what type of functions. So I know how to graph.
Linear.
Excellent. Who said that?
Column.
Thank you. So remember, for linear, I prefer x and y intercepts if I can. Okay. So for now, and I only need 2 points. So for now, I'm going to plug in 0. When I plug in 0, can anyone tell us what we get?
-1.
Excellent. Now, can you plug in 2 here? I know you're going to say no, and I have to agree with you. I'm asking you to plug in 2 in a function, but 2 is not in the domain of that piece. Well, if you say, and you're correct, don't plug in 2 here, you can't, I will say, yes, I agree with you, but in that case, you will have to plug in 1.99999999999. So plug in 1.999 in there. Of course, you're going to say, no, I don't want to do that. So bear with me and plug in 2. And we write right here inside a parenthesis. What do I write in here?
0,
That's
0.
zero.
Very good. Say it again.
That's 0. 0.
Good. Perfect. So this is done. It happens that I have x and y intercept. On this side, I want you to plug in 2 again, and you're going to be appalled. And again, you're going to say no. But then I'm going to say, in that case, plug in 2.00000000001. Because if you start at 3, you miss all real numbers between 2 and 3, and there are infinitely many. So then I guess you're going to agree with me and then plug in 2. What do we get?
-1.
-1. And of course, we have to plug in 3 because that will be an x-intercept. So plug in 3 and tell me what to get.
0.
Excellent. Good. So now let's continue with the graph. This function has 3 pieces. Just to make a point, of course that is not necessary, but just to make a point, I'm going to use 3 colors. Okay? I'm going to use this color for the left branch. Okay. 0, -1. 2, 0. Is this a full point or an open point?
Open.
Very good. Why is it open? Because there is a parenthesis here. So 2, 0 will be this. I'm connecting and extending, and I'm done with the left branch. The middle branch has 2, -4. Full point or open?
Open.
2 comma negative 4.
Sorry, it's closed.
Very good. I'm done with the second branch. Now the third branch. 2, negative 1. Is this a full point or an open point?
Open.
Very good. It's an open point. 3 comma 0. And this is it. This is our function. If I make the mistake to extend the green to the left, and if I make the mistake to extend the whatever this color is to the right, this is no longer a function. By the vertical line test, it's not a function. That would be a terrible mistake. But now, by the vertical line test, everywhere, every line, vertical line, will cross the function in only one point. If we want to identify the range, since this goes on forever and this goes on forever, what will you say the range of this function is?
Negative infinity to positive infinity.
Thank you very much, Colin. Excellent. So this is the way we graph a piecewise defined function. It was a very good pick. Thank you very much. And you'll see what happens to this in chapter 1. Any questions? Is this clear? Any questions for me, please?